everyone. Today we're going to talk about something called the unit circle. We're going to learn more about angles and reference angles, a lot of terminology that's going to help us become great at trigonometry. Now, I like to think of the unit circle, I call it my best friend when I'm dealing with trigonometry, because if we understand some of the basics of it, then I don't have to memorize 20 or 30 different pieces of information. I just kind of have to understand what sine is the ratio of and cosine. And then there's a whole lot I can do with the unit circle. So let's start day one. We're going to start with our warm-up. Okay, some geometry practice here. I want you to find the missing angles. So find x and find m. Pause the video, think about how you do it, and then when you're ready, we'll look at the answers. Okay, so hopefully you noticed that these two angles make a straight angle. So 127 plus x is 180. They're supplementary. So x has to be 53 degrees. And then 19 and m are complementary, which means they add up to 90, which means m has to be 71 degrees. We're going to use these concepts today on the unit circle to find missing angle measures and find angle measures that have the same sine and the same cosine. So we're going to still deal with some trigonometry, but we're going to start with some triangles. So now this is a special right triangle. Maybe in a geometry class or a previous class, you've talked about 30, 60, 90 triangles and 45, 45, 90 triangles. I'm going to use this to help me find an angle in the plane. We're going to find angle theta, but first we got to find angle beta. So to do that, there's a ratio here where if I see my small leg is x, my bigger leg is x root 3, and my hypotenuse is twice the length of x. So in this case, this triangle on the graph comes from this special right triangle. Now, if it follows these ratios, this is a 30, 60, 90 triangle, where the smallest leg is opposite 30, beta in this case is 60 degrees, and we got the right angle. So this angle beta in both these triangles is 60 degrees. So that makes theta 120, because 120 plus 60 is 180 degrees. And this coordinate point, coincidentally, is -4 on the x and 4 root 3 on the y, because the base length is 4 and the height is 4 root 3. So this angle, if we start from here, and we're going to learn that we always start from at 0 degrees, is on this right section. So this is 120 degrees. But we can also name this orange line a bunch of other angle measures. So we can go counterclockwise, which we're going to define as positive, 120 degrees. But maybe I want to go the opposite way. So I want to go in the negative angle measure, and I can go negative 240 degrees. Or maybe I want to go crazy. I want to do a lot of spins. So I want to do 1, 2 full spins and then a piece. So I can take my 120 and then I can add 1 spin, which is 360. And then I can add 2 spins, which is 720. And then I can add the 120 to get 840. So I can do 120 plus 360 plus 360 plus 360, however many times I want. So we represent this by saying it's 120 degrees plus 360k, where k is an integer. Okay, or as a positive angle, k has to be a positive or a natural number. But k can also be negative if I want to spin backwards. So there's an infinite amount of angles that have the same standard position. Okay, this angle right here, we said was 840, and we said was negative 240, and it's positive 120, and there's a bunch of other angles that would be the same. So I want you to try it. Okay, remember 0 degrees is over here. I want you to find the positive angle, the negative angle, and then an angle greater than 360 for each one. Pause the video, try it out. When you get an answer, we'll check them. So taking a look here, this angle is positive 180, or this angle is negative 180, or we can go 180 plus another 360, which is 540. So you could have added 360 however many times you wanted to 180. So 540, and then 900, and then 1260. Keep adding 360. All of them wind up in the same spot over here on the left. And for part B, we go almost 270, but it's 25 less. So it's 245 degrees. Or I can go backwards 90 plus 25, which is so backwards 115, negative 115 degrees. Or I can go 245 degrees and then give it a bunch of spins, however many spins of 360 I want. A lot of times we're going to be dealing with the positive angle, but sometimes the negative angle might be more useful. And sometimes we just want to know the ending point, so we have to remove a lot of 360s to get it back to an angle between 0 and 360 degrees. Now, this is useful because in trigonometry, if we understand the concepts and we can get the angle in the first quadrant between 0 and 90, all of the angles that are greater than 90 are going to match with an angle in the first quadrant. So there's this concept of a reference angle. Now, what a reference angle is, okay, it's the acute angle. It's how far the angle is from a horizontal, from the x-axis. So we're always going to sketch the picture. We got to figure out where the angle is, and then we're going to figure out how far it is from the x-axis. We're going to draw a small triangle. So 130 degrees is in the second quadrant. It's past 90. 90 is at the top. 180 is over on the left side. So 130 degrees is here. And then we got to figure out how many degrees is it to the horizontal. So we got to get from 130 to 180, and that's 50 degrees. Now you could do any type of calculation you want. I just like thinking in my head, how far am I from the horizontal? And it's always a positive number between 0 and 90. Now here's a little diagram on the left if you forgot what the angles are or what are the names of the quadrants. Because the problem may say I want a quadrant 2 angle or quadrant 3 angle or quadrant 4 angle. We got to know which quadrant we're in. But all of these angles are going to match 50 degrees. Okay, they're going to share a lot in common with a 50-degree angle. So down here, if I want to go 50 past 180, I could have a 230-degree angle. Or maybe I want to go 50 less than 360, and I could have a 310-degree angle. Or a negative 50-degree angle. Whole bunch of ways I can name it. They all are going to have a reference angle of positive 50 degrees, and we're going to learn a lot of information we can do with that reference angle. Now, a problem could say, what's the reference angle for 210 degrees? So once again, we draw the picture, and we figure out how far it is from the horizontal. So I see that this is 210. The closest horizontal is 180 degrees. So I know it's 30 degrees. Past the horizontal, the reference angle is 30 degrees. Okay, if they tell you about an angle, I would draw the picture, figure out where the angle lies, what does it look like, so we can deal with it. Because a problem may say a reference angle is 45 degrees and it's in quadrant 4. So I know it's 45 degrees away from a horizontal plane in quadrant 4. The quadrant 4 is this one. I know it's down there. And I know it's 45 degrees away from that. So I need to know a positive and a negative. Negative is pretty easy in this case. I start here and I go clockwise, so it's just negative 45 degrees. Okay, but if it's positive, okay, I go 315 degrees because I have 360 minus 45. Because this angle here is 0 and it's 360 because we can have either 0 spins or a full spin. So 360 minus 45, or in this case, negative 45, because we start and we go backwards in the negative direction, which is clockwise, negative 45 degrees. So you give it a shot. I want you to tell me the reference angle to a 10-degree angle, or the angle with a reference of 10 degrees, but it's in quadrant 3, and an angle that's got a reference angle of 15 degrees in quadrant 1. Give me a positive and a negative. Try it out. Okay, let's take a look how we did. So 10 degrees in quadrant 3, which means quadrant 3 is down bottom left. Okay, I know this has got to be 10 degrees, so it's 180 plus 10. Or we can go backwards almost 180, but 10 less. So we can go backwards 180 minus 10, so negative 170 degrees. 15 degrees in quadrant 1. In quadrant 1, those are our reference angles. You could add a 360 to it and say it's a 375 degree angle too. You could add another 360 to that. And then you're going to notice that these two angles, okay, the positive and the negative, have to add up to 360. Because if we're going in one direction or the other direction, the whole circle is 360 degrees. And this brings us to what I've called my best friend in trigonometry, the unit circle. So the unit circle, okay, has a radius of 1. So the radius is always 1. So the height and the base are always going to be less than or equal to 1. And the height is the sine ratio, and the base is the cosine ratio. So if we can imagine every time, what's the base? Is it a long base or a short base? Is the x positive or the negative? Is the y positive or negative? We can tell whether the sine of an angle is positive or negative, all based on right triangle trigonometry. So if I give you the sine of an angle, before you throw it in the calculator, you can think, well, does that have a positive height? Okay, that might be positive, and then we can go from there. So with this, I strongly encourage you to find a blank unit circle. They're all over the internet, and print it out. And we're going to fill it out piece by piece as we go through this chapter, talk about angles and coordinates and the sine and the cosine and anything else we need. So I'd print that out or draw it by hand, and we're going to have all of these angles measured, and we're going to know what the angles are and what the coordinates are and the sines and the cosines of every single point on here. And with this, we're going to get into some special right triangles. So an angle has a measure of 60 degrees and a terminal side. So it means it ends on the unit circle at the xy coordinate. We need to figure out what x and y are. So like we've been doing this whole lesson, we're going to draw a picture to start. Okay, and I know that theta is 60 degrees. So step one, always draw the picture. Make sure you know what it's going to look like, and we can go from there. Then we talked about sine being the height ratio and cosine being the base ratio. So if I knew the sine of 60, I know y. If I know the cosine of 60, I know x. Now we need to know some special cases, because if I put sine of 60 in my calculator, it's going to give me a number, but it's going to give me an ugly decimal, and I want an exact value. So in a 30, 60, 90 triangle, okay, if we have the 60 here and the 30 here, there's a special relationship that we'll talk about. if the hypotenuse is 1, which we said it is because the radius is 1, then the base is going to be 1/2. The side opposite 30 is 1/2. And the side opposite is square root of 3/2. So in this case, I can draw that triangle on my circle, and then I get that the x is 1/2, and the y is square root of 3/2. And that's my coordinate point. My point is 1/2 almost square root of 3/2. That comes from the special 30, 60, 90 triangle. That's one we will go over, we will talk about a lot, because the 30, 60, 90 triangle has a lot to do with most of the points on the unit circle. So sine of 60 is the square root of 3/2, because it's the height. The cosine of 60 is the base, the x value, which is 1/2. Now, once again, my calculator is not going to tell me sine of 60 squared of 3/2. It's going to give me an ugly decimal. So I need to know some of these special angles. Now you try it out. See if you remember what a 45, 45, 90 triangle looks like. If not, we can talk about it together. But at least draw the picture. Think about what this is looking like. Okay, so you tried it out. So here's the ratio for a 45, 45, 90 triangle. The two base legs are the same because it's an isosceles triangle. If it's a 45, 45, 90 triangle, two of the sides have to be the same. So if the radius or the hypotenuse is 1, then the side lengths are square root of 2/2. So in this case, both coordinates are the same. And the sine of 45 and the cosine of 45 are both square root of 2/2. And those will help us figure out more points on the unit circle. So in the next lesson, we're going to talk more about this, where we have the 45, 45, 90 triangle, we have the 30, 60, 90 triangle, and we're going to be able to rotate the 30, 60, 90 triangle to get more points in the unit circle. We're going to continue to understand when sine is positive and negative, and that sine represents the height, so the y-coordinate is always the sine of the angle, the reference angle, and the x-coordinate is the base, or the cosine of the angle. So cosine of 30 is square root of 3/2. Sine of 30 is 1/2. And we're going to learn more patterns as we deal further with sine and cosine.